We have this question: solve a second differential plus 4y equal to sine t times u of t minus 2 pi. Unit step function of t minus 2 pi. And then we have the conditions here: y of 0 is 1, y prime of 0 is 0. So the first step is to take the differential, take the Laplace of both sides. Since we are using Laplace method, take the Laplace of both sides of the equation. Laplace of 4y, then Laplace of sine t u of t minus 2 pi. So this will give us Laplace of transform of second differential will be s squared, Laplace of y, then minus xy of 0 minus y prime of 0. That is for the second differential. Then plus this one will be 4, then could be outside, and then Laplace of y. Okay, Laplace of y, and then equal to, this will be equal to exponential minus 2 pi x, and then Laplace of sine t, Laplace of sine t, and we can put t, okay, t plus, that will be t plus what we have here, 2 pi, t plus 2 pi, t plus 2 pi, t plus 2 pi by the side of that equation. Okay, and what meaning of that t plus 2 pi means is that just this Laplace of this function, if it has a t, that t will be replaced by this. Okay, so that's what we have now. Then this will now give us this y of 0 is 1, y prime of 0 is what? 0. So we now have x squared plus 4 Laplace of y of x. Okay, then minus x1 times x times 1 equal to e minus 2 pi x. Then Laplace of sine is just 1 over Laplace of sine is 1 over x squared plus 1. So there is no t in this expression. So this is of no use. So 1, Laplace of sine is 1 over x squared plus 1. You just have to look at attachment of your t is 1. So 1 over x squared plus 1. So if you have a 2 here, it will be 2 over x squared plus 4. So in this Laplace now, in this expression now, there is no t. So this will be discarded. It's of no use in that. So then the next thing to do now, we now have s squared plus 4 into bracket Laplace of y equal to e minus 2 pi x over s squared plus 1, and then plus what? Plus x. Okay, can we divide by, make the Laplace the subject? So that will be equal to Laplace of that equal to, we can separate this e minus 2 pi x times 1 over s squared plus 1, and then we are dividing by s squared plus 4 through the equation s squared plus 4, then plus x over s squared plus 4. So this is what we have now. Then the next thing to do is to get the Laplace of take the inverse of both sides, and that will be equal to what? If you take the inverse of the Laplace, that will give you this equal to inverse of this, which is e minus 2 pi x times 1 over s squared plus 1, s squared plus 4. Okay, the inverse of what? Inverse of x over s squared plus 4. Okay, so that's what we have now. Then the next thing to do now is to, first of all, this fraction here, you can resolve it into partial fraction. Okay, then we'll come back again to this place. So let's take this one now and solve it. S squared plus 1, S squared plus 4. So they are both quadratic. I mean, the denominator are both quadratic, and you cannot factorize them. So this, for this one, will be ax plus b over the what? S squared plus 1. So if you have a quadratic, if you are solving in a partial fraction and you have the quadratic at the denominator, which you cannot factorize, it's very simple. You write the linear of this ax plus b over this, then plus the next one also. It will be where you stop here is b. You continue cx plus d linear over the one s squared plus 4. So then we can solve this, and this will be equal to 1 multiplied through the equation by s squared plus 1 times s squared plus 4, and that will be equal to 1 on the left, and this will be ax plus b times s squared plus 4, then plus s squared plus 1 times cx plus d. Okay, so that's what we have now. Substitution will not work in this case. It won't work in this case. So what we can do is to expand and equate coefficients. Expand and equate coefficient. This one times this one. Let's keep ax times 4, that's 4a. B times this plus bs squared plus 4b. Then the next one plus s squared times cx cube plus d s squared, then plus cx plus d. So let's equate coefficients. S cube we got to what? On the left we don't have that 0. That will be a here, a plus c, coefficient of s cube. That's equation 1. Equation 1. Coefficient of s squared we don't have also on the left, and that's s squared. That will be here. That's b followed by s squared plus d. Equation 2. Then coefficient of so now we have s cube, we have a plus c equal to 0, s squared coefficients, we have b plus d equal to 0. What again? Coefficient of x, let's check that. That will be 4a plus x, 4a plus d. No, is it d? 4a plus c is here. Coefficient of x, 4a plus c equal to 0. And cosine terms. Cosine terms, we have 1 on the left. And let's check the cosine terms. That will be 4b. Cosine terms, 4b is here. And then d plus d. Okay, so these are the 4 equations we were able to extract. There are 4 equations. So let's see how we can solve them. Equation 1 and 3 can be solved together. They have the same cosine a and c. So equation 1 times 4, okay, combined with 3. 1 times 4 plus combined with 3. So and that will be equal to what? 4a plus 4c equal to 0. That's 1 star. Then 4a plus c equal to 0. Subtract them. So equation 1 times 4 minus 3. 4a minus a, that's 0. 4c minus c, that's 3c equal to 0. C is 0. Okay, can we substitute also into the end of the equation? You can use this one. Substitute there. 4a plus c is 0. And 4a, c is 0. A also is also 0. So that's done. Can we combine 2 and 4? 2 and 4. And equation 2 times 4 also. So equation 2 times 4, which is 4b plus 4d equal to 0. Then equation 4b plus d equal to 1. So this is what we have. Then we can subtract 4b minus b, that's 0. 4d minus d, that's 3d, equal to minus 1. 0 minus 1. So d is what? Minus 1 over 3. So with that, we can go to any of the two equations here, 2 and 4, and substitute there. So let's use this one, 4b plus d. My d is 1 over 3, equal to 0. You can get b. Let's go to equation 2. B plus d is what? Is 0. So b plus minus 1 over 3 equal to 0. So b is what? B is 1 over 3. So we've gotten that also. Okay. Therefore, we we can go back here, this place, and substitute what we got. So 1 over s squared plus 1 into bracket 1 over s squared plus 1 into bracket s squared plus 4 equal to, my a is 0, so I only have b. B is 1 over 3, 1 over s squared plus 1, then plus c also is 0, so d is minus 1 over 3 over s squared plus 4. We can take 1 over 3 outside, minus 1 over 3 can be taken outside, and that will be equal to what? 1 over s squared plus 4, then minus here, 1 over s squared plus 1. So we have that. Then we can go back here, and the solution will now become y equal to inverse of e minus 2 pi x, okay, of minus 1 over 3 1 over s squared plus 4 minus 1 over s squared plus 1. We can close that. Okay. So then plus inverse of x over s squared plus 4. The last part here. Put that there. Okay. So we now have this will now give us, we can bring this minus 3 outside, and that will be equal to what? That will be equal to inverse of minus 1 over 3 e minus 2 pi x Laplace of what? 1 over s squared plus 4 minus 1 over s squared plus 1, then plus inverse of x over s squared plus 4. So that's what we have now. So we can, the inverse of this of e2 pi x will be that will be equal to ut minus 2 pi. We can return that back, and that will be that back to the original form. You take the inverse of this exponential form, you have this, and you can put your minus 1 over 3 by this side, and that will be equal to inverse of what? Inverse of 1 over s squared plus 4 minus 1 over s squared plus 1. When you have unit step, you have to also put that there, t minus what? T minus 2 pi. Okay, t minus 2 pi, then plus inverse of x over s squared plus 4. The essence of t minus 2 pi is that the moment you do your inverse of this, you do the inverse of this expression. So anywhere you see your t, you put t minus 2 pi there. Okay, so that's that on that. So we now have I want us to know that the inverse of this, ideally, inverse of 1 over s squared plus 4 will be equal to, this is 2 squared, so we expect to have 2 here also, 2 over s squared plus 4, inverse of that. Then these 2 also that you introduce here, you have to cancel that outside, and that will be equal to half sine 2t. Okay, Then also the inverse of 1 over s squared plus 1 will be equal to what? Sine t. Sine t. Okay? So let's now go back to this place and do the imputation there. So, and that will be equal to y equal to minus 1 over 3 u t minus 2 pi. Okay, then you open your brackets. Inverse of this is what? We have it already. That will be half sine 2. Anyway, you see t, what do? You put t minus 2 pi there. T minus 2 pi. Okay. Then the second one, minus sine t, inverse of 1 over s squared plus 1. So that's sine t. So anyway, you see your t, you put t minus 2 pi also there. So you can close your inverse there. Okay. So then finally plus what? Plus the last one, which is what? Which is cos 2t. So that's the answer. So let me just if you would like, we can open it. You can open the bracket, which is equal to what? Which will be equal to minus 1 over 3 times 1 over 2, that's minus 1 over 6, u of what? T minus 2 pi. Okay. Sine what? Sine 2t plus what? Plus 4 pi. Okay. Then minus times minus, that's plus. That's plus. That's 1 over t, 1 over 3, u t minus 2 pi sine what? Sine t minus 2 pi. Then plus cos 2t. So that's just that to that question. You're wondering why we don't replace that t here. Don't forget that it comes separately from the Laplace transform. So it's different. It doesn't have exponential there. It comes separately from the left-hand side. So that's just that. Okay. So, and don't forget, please, the inverse transform of this, we return it back to original form to the original form, which is what? Ut minus what? 2 pi. Okay. So that's just that. And don't forget, once you have this one, you must have it back as your time domain. Okay. So anything you have now in the inverse, okay, that contains c, you have to replace that t with that. Okay. So that's that on that question.